Hello everyone, I am Meenakshi, Assistant Professor EEE Department in KSR College of Engineering. In this video, we are going to discuss about different types of coupling methods. The first method is RC coupling. The figure shows the RC coupling method using transistors. In this method, the output of first stage is connected to the input of next stage through coupling capacitor and the resistive load. The RC coupling method is most frequently used method and it requires less cost. It has an acceptable frequency response. In this method, the developed signal across the collector resistor of every stage is coupled throughout output coupling capacitor toward the base terminal of the next stage. The coupling capacitor, it blocks the DC states from the primary stage to the below stage. The coupling does not affect the Q point of the next stage. Since the coupling capacitor blocks the DC voltage of the first stage from reaching the base of the second stage. It is broadband in nature. The wide frequency response without peak at any frequency. It is used to cover a complete amplifier bands. However, its frequency response drops off at very low frequencies due to coupling capacitors and also at high frequencies due to shunt capacitors. This is the frequency response characteristics of the RC coupled amplifier. Advantages is simple and inexpensive, compact in size, good frequency response over the audio range, and it is widely used in voltage amplifiers. Disadvantages are poor impedance matching, gain decreases at very low and very high frequencies. It is not suitable for power amplification. The applications are audio frequency amplifiers and pre-amplifier stages. The second method is transformer coupling. This is the transformer coupling method using transistors, and the output of first stage is coupled to the input of next stage through the proper impedance matching transformers. In this type of coupling, the signal expands across the main winding of the transformer and it performs as a load. This method enhances the total gain and matching level impedance. This is the advantage over RC coupling method, but the transformer using a wide frequency response can be extremely expensive. This is the frequency response characteristics for the transformer coupled amplifier. The advantages are excellent impedance matching, high power transfer efficiency. It is suitable for power amplification. The disadvantages are bulky and inexpensive, limited frequency response, magnetic hum and losses may occur. Applications are power amplifiers, audio output stages. The third method is direct coupling amplifier. In this method, the output of first stage is directly coupled to the input of the next stage. The direct coupling allows the quiescent DC collector current of first stage to pass through base of the next stage. It affects the biasing conditions. Due to absence of RC components, frequency response is good, but at higher frequencies, shunting capacitors reduce gain of the amplifier. This is the frequency response of the direct coupled amplifier. Advantages are it amplifies very low frequency and DC signals, no coupling components requires wide frequency response. Disadvantages are DC biasing problems, temperature variations affect operating point, design complexity. Applications are DC amplifiers, operation amplifiers and instrumentation amplifiers. These are the comparison of coupling methods. In RC coupling method, cost is low, size is small, wide frequency response, and the application is audio frequency amplifiers. In transformer coupling method, cost is high and the size is so bulky. The frequency response is limited and it's used for power amplifiers, excellent impedance matching. The third one is direct coupling. Cost is moderate and the size is small. It is very wide frequency response and the applications are DC amplifiers and instrumentation amplifiers. Thank you.